Okay, in this video we're going to be looking at how to express domain, range, and general sets of numbers. We're going to work with real numbers on this one in a variety of different notations. And so for the example that we're looking at now, we're going to look at all numbers that are between -2 and 5, including 5. That's going to be an important part here, or the numbers that are larger than 8. The first thing that we're going to look at here is expressing this on a number line. So we will look at the number line version of this. We need a number line to put that on. We're going to mark important points that are on there, like -2 and 5 and 8. We want the numbers that are between -2 and 5. Graphing of any kind, including a number line, is about covering up the answers that work. -2 is a boundary answer, so -2 itself doesn't work, but it serves as a boundary. 5, the including 5 part, means that we're going to need to color in the dot on the 5. That says it's a boundary, and you can use that boundary. And then we use a segment to connect those to indicate that all of the numbers in between there work. And then the OR says I have a second part of this. We want the numbers that are larger than 8. It doesn't say that 8 works, just the ones that are larger than 8. So we're going to get a circle there, and we will cover up the numbers that are bigger than 8 out here to the right, like 9 and 10 would be out here and covered that direction. So that's what our number line looks like. Second thing that we're going to look at is expressing this with inequalities. And our inequalities, that's using the less thans and the greater thans and things like that. The between notation, we actually have a little shortcut that we can use for that. And so we put the smallest number that works, and then the numbers between -2 and 5, so we're going to put the 5 out here as well, and we'll put our x, whatever the variable happens to be, in between there, and we'll trap that with some less than signs. Now the fact that it says it includes 5 means that we actually want a less than or equal to there. In this notation, we actually have to grab the word or that it was using above and say it is going to be the numbers that satisfy that inequality or the numbers that satisfy our next inequality, which is all the values of x that would be greater than 8. So that's what the inequality notation looks like. The next one we'd like to look at is interval notation. Interval notation we like, it's nice and compact and takes care of things. It basically is an interpretation of these inequality symbols that we had up here. The less than sign without the equal to part becomes an open parentheses, and we bring in the -2, 5, the less than or equal to, the equal to part makes it a closed parentheses, and so we see this interval here that is taking us from 2 to 5. And we get all those points in between. Tells us not to use the 2 with the open parentheses, but do use the 5. And then our OR becomes what we call a union symbol in this notation, which is just a U without the tail on the end. And when we want to express the x greater than 8, again, because it's just greater than that 8 boundary is an open parentheses, and that will go on then forever, so that becomes an infinity out that direction, and infinity always gets an open parentheses because it's not actually a number in itself. All right, and now we're going to look at the what's called the set builder notation. Set builder notation uses a different grouping symbol. along the way. So it always starts out with a curly bracket, and this part is read as the set of all x such that, the vertical bar means such that, so we have the set of all x such that, and then we borrow all of the inequality notation that we did before, such that x is between -2 and 5, including 5, or x is greater than 8. It feels like it's more than what the inequality thing was, but there will be, in our second example that we do in the next video, we'll see that there's a reason for this, and there are places where that will work. And then finally, the last notation that gets used is called a roster notation. The roster notation is basically a list of all of the numbers that work. In this case, because we're dealing with all the real numbers in this, that's impossible to do this list, so we can't do the roster notation with this particular example. And that's it for this example. Hopefully all of those made sense.